Hello, my name is Andrew Russ, and this is homework 4, the technical interview question. It's 1:37 now, so hopefully by the end of this it's 1:47, and I've exceeded my 10-minute time allotment. Please excuse, I know the background's not the most professional. This is as good as I could do with what I had, so please, bear with me. Anyways, as you can see here on the left is our first question, and probably going to be the only question, called to-sum. Essentially, in a technical interview, this is a fair game question. It's on the easy list for LeetCode, and it's asking me, given an array of integers, nums, and an integer target, return the indices of the two numbers such that they add up to target. So, on here I'll take notes on the right. Returning indices, so we'll probably start with that because that's super easy. Indices, and then we may assume that each input would have exactly one solution, and you may not use the element twice. Now, if this wasn't here, this is a question I would ask the interviewer: can I use the same element, or is the same element possibly used twice? So for instance, if we were given an array 3, 3, 4, 5, and the target was 9, would it have to be 4 and 5, or could it be, or sorry, that's actually a bad example, 3, 4, 5, 6. Could it be, say the target was 8. 3, 4, 5, 6 is the array and the target's 8. Would it have to be 3 and 5, or could it be 4 and 4? So that, in ascertaining this, we gather information that's relevant to the solution. So this is a question I would have asked if it wasn't explicitly stated, but it is, so we should be good. No same element twice. And then you can return the answer in any order. We're just going to return it the most basic way: the first element we see, then the second element we see, in that order. But I mean, you can do either way, no problem. And then we got some examples here. So if we have 2, 7, 11, and 15, we would expect that to get to the target 9. We get the first two indices, the 2 and the 7. Now, obviously, according to the answer, or according to the prompt, we could have it indices 1, 0, but we won't. We'll just have it simple. And then you can see it, not the first element, easy peasy. So, having said that, we will now get right into the actual coding portion. So, immediately it had said that we are returning the indices, right? So the indices will be put in a vector, but we don't really need to assign a vector. We could make a vector of ints, return vector, easy enough, right? But we won't, because it's actually a little worse. I'll explain why as we get there. But so anyways, let's look at the problem logically. We're going to find the two numbers, right? And the two numbers are going to be summed with any other number, right? So logically speaking, I'm going to have to test each number with every other number to verify that this number has no valid solutions, or it does have a valid solution with another number. And that screams double for loop. And so we'll build the structure for that really quickly. So we'll start with the outer loop. Int I equals 0. I is less than the size of nums. And then I plus plus, because we're going to increment for each time. And then inside of that for loop, we're going to have another for loop, because this is going to, that first one is the outer number, if you will, the outer iteration. So if we have the array 2, 3, 4, 5, I will start at 2, and then it'll check every other number. So remember, we weren't checking with ourselves, so it won't check 2 again. It'll check with 3, 4, and 5, and then it will increment, and then it will check, J will check 3, or sorry, it'll check 4 and 5, because I is now 3. So what that looks like, instead of saying for j is equal to 0, j, excuse me, is less than size of nums, and then j plus plus, it's actually going to look a little different because we can't have the same number. This is actually I plus 1. And what this is saying is that instead of starting with our 2 here, remember the example again, the 2, 3, 4, 5, our array like this. If we start here with 2, then the next number that's going to be compared with is our 3. So 2, 3, so I would be 2, and then j would be 3. And there's only going to be one more. So as we iterate through it, I'll draw it rather. I equals 0, and then it goes 1 to 2 to 3 as the indices for a 4-element array. And then we have j, which will start here, right? And then I will compare with j, so these two elements will be compared. And once that's done, j increments, which then compares these two, and then it will do this. And then once all of those are compared, we say, all right, well, this isn't it. It's not, I is no longer there. I is now moved to here because it has now incremented as we've checked everything else in the double for loop. So now, when we're assigning j, we don't assign it back to here because we don't test it with itself, and we don't do it here because this is already pair has already been checked. And so j will always be what I is plus 1 for the beginning, which means we can then iterate there and save a little, runtime instead of being wasteful rather. All right, so now that we have our outer structure, we got to determine if our return condition is met. So we're going to do that with an if statement. So if nums of I plus nums of j, remember I and j aren't the same number, so the sum of those is exactly equal to our return value, which remember is passed in as target, then we're going to return the indices, right? And so we'll make the vector here as the indices. So instead of making a new vector and then calling that variable down here, we'll just return it like this. And this is actually a slight optimization. In doing this, if we were to make a new vector and then call it down here, we're actually, because we're assigning that vector, we're making it a little worse on memory. I can't remember exactly if it's worse on runtime, but if it is, it's minute, as this is going to be O of n squared anyways. To get it less than O of n squared, we'd have to use, I believe, a hash map, which is a little beyond the scope of this class, I believe, so I'll keep it to this. So anyways, we'll return our two indices, right? So the indices are our I and our j, not the numbers that are corresponding to them. So we'll return I comma j. And then we'll also have a little safety down here, return -1 if it turns out that our function didn't work properly. We'll see that. So just to verify before we send it in, we have a for loop on the outside for I, and then it's squiggly brackets met, for loop on the j, structure looks good, squiggly brackets met, if looks good, squiggly brackets met, and there's a return on the inside, and then there's a safety return. This should be good to run. See if we get any error. I do have an error because I forgot to initialize my j variable. So let's try it again. Got a compile error. Oh, because we're returning a vector, right? So I will return an empty vector. One more time, hopefully. No more embarrassment. Okay, so there we go. We'll now submit it to the actual grader, which will test it more thoroughly, and it looks like our results accepted. Phenomenal. So let's see what we could have done better, and I'll get into it a little bit. So the runtime is not super optimal, but for this type of solution, it seems on par. There are obviously better solutions. I'm sure there's people that spend a lot of time on this, but for this looks fine. And then for memory, we have an incredible memory usage here. This is better than 99.55%, so we'll be very happy with that. And I believe one way to improve the memory, although I'm not sure, so I won't get too deep into it, is to set a variable to size of nums, because I believe calling size nums actually is a little more taxing, maybe not on the memory rather, but on the runtime. And where if we don't have to do that function size call, we just know that the variable is set there, then when we call it again, in both for loops, it's actually saving one call, so it's slightly better. Although by and large, if you were to do this for large sets, I don't believe it would be significant. And so we'll leave it at that. Anyways, my name again is Andrew Russ. I believe I did hit my 10-minute time mark. If not, you'll be seeing me again. And I appreciate the opportunity to do this. This is actually really nice. So thank you.